All right, let's talk NVIDIA. They've just unveiled their next-gen Rubin platform. And believe me, it's way more than just a new chip. It's about to kick off a massive revolution. And today, we're going to deconstruct exactly how this radical new design is set to completely reshape the AI hardware value chain. Okay, so you read a quote like that, and it's a lot of corporate speak, but what does it actually mean? Well, to really get the leap from Blackwell to Rubin, you have to stop thinking about a faster chip. NVIDIA is playing a much bigger game. They are re-architecting the entire AI factory, as they call it. And wow, just look at these numbers for a second. This isn't just an incremental upgrade. It's a monumental leap in performance. By literally doubling the speed of the data highway between all the core components, NVIDIA is triggering a massive chain reaction. An upgrade this big forces everyone down the line to level up their game. So here's our game plan. We're going to trace that exact ripple effect. We'll start with the new architecture itself, then dive into how it impacts everything from cooling and materials all the way down to which companies are poised to win big from this shift. All right, first up, how is Rubin even achieving this? The secret sauce is a philosophy they call extreme co-design. Instead of thinking of a server as just a box full of separate parts, they're designing the entire rack to function as one single integrated system. And here's the whole team. It's not about one star player. You've got these 6 distinct chips, all designed from day one to work together in perfect harmony. By doing this, NVIDIA is essentially designing the bottlenecks right out of the system, which is how they're maximizing efficiency at an absolutely massive scale. Okay, so you pack all that incredible computing power so close together, and you inevitably create one giant, unavoidable problem: heat. An incredible amount of heat. With Rubin, liquid cooling is no longer a cool high-end option. It's a mandatory, non-negotiable standard. Think about this. A single chip is expected to kick out over 1,000 watts of heat. That's more than a lot of kitchen microwaves. At that point, traditional fans and air cooling, they're completely useless. It's like trying to cool a bonfire with a hand fan. This forces a total revolution in how we manage heat, and it opens up a brand new, very lucrative market. So who steps in to solve this massive thermal challenge? Well, this is a golden opportunity for Taiwan's cooling specialists. We're talking about companies like Qihong, Shuanghong, and Taidadian. They're in the perfect spot because they're not just selling simple parts. They're delivering the complex, high-value, integrated liquid cooling systems that NVIDIA now requires. Now, there was a little bit of confusion in the market about this. When people heard about using warm water cooling, they thought, oh, so you don't need as much cooling hardware. But that's not it at all. Let's be really clear. This new, more efficient approach actually increases the need for the advanced hardware, the cold plates, the distribution units that these Taiwanese firms are experts in making. The value is going up, not down. Okay, so we've got the heat under control, but it's not just about temperature. To handle double the data speeds, you have to completely rebuild the electronic highways that carry all those signals. And that brings us to a high-stakes race for advanced materials. This is where we get into something called copper-clad laminates, or CCLs. You can basically think of them as the foundational material that circuit boards are built on. And as you can see, we're on a super fast evolutionary track here, moving from the current M7 standard all the way up to an ultra-high-performance M9 grade that's absolutely essential for Rubin's fastest pathways. Which, of course, brings up the obvious question, right? If M9 is the absolute best material for the job, why on earth wouldn't NVIDIA just use it for the entire system? Well, the answer is fascinating, and it all boils down to a single critical supply chain bottleneck. See, to make true M9 grade material, you need a special ingredient called Q-glass. And this isn't just some off-the-shelf component. It is so rare and so difficult to produce that it's basically considered a strategic global resource. So what do you do when a critical resource is that scarce? You get clever. NVIDIA is making a brilliant engineering compromise. For the main, high-volume parts of the system, they'll use a slightly less exotic but much more available material they're calling M8.5. And just like that, this one strategic decision creates a massive opportunity for a company like Tokyo to step in and become a critical new supplier in the ecosystem. Remember that extreme co-design idea we talked about earlier? Well, here's another huge consequence of that philosophy. It completely changes how these servers are physically put together. We are moving away from a rat's nest of internal cables toward a super clean, modular, plug-and-play design. So where does the money go? This table maps it out perfectly. It's a great migration of value.
The money is literally moving away from things like complex internal cable assemblies and shifting directly into things like highly advanced circuit boards and incredibly sophisticated new sockets and connectors from suppliers like Kazai.
Now, it's really important to get this right. When you hear the term zero cable, it doesn't mean all cables have vanished. It specifically refers to the connections inside the server box. The value is just shifting from that messy internal wiring to the much more complex circuit boards that replace them. And, funnily enough, to even more advanced, high-value cables needed to link all the racks together. Okay, so let's pull all these threads together and look at the big picture. The shift to Rubin is so much more than just a typical product cycle refresh. It's a fundamental reshuffling of the entire supply chain deck. And in this new game, Taiwan's most advanced technology suppliers are holding some seriously powerful cards. You know, this table really tells the whole story, doesn't it? In every single critical technology shift, whether it's cooling, advanced materials, or the high-density modular design, the value is migrating away from simple individual components and toward these highly complex, integrated subsystems. And as you can plainly see, Taiwanese firms are right there at the forefront, leading the charge in every category. So the Rubin platform is an absolutely brilliant solution for today's biggest challenges in compute, communication, and cooling. But you know how this relentless pace of innovation works. As soon as you solve one massive bottleneck, all you really do is reveal the next one. It leaves us with one final, fascinating question to think about. What new challenge is about to emerge as the next major hurdle for the entire AI industry to conquer?